Hello viewers, I am Deepti Hans. In your previous classes, you have learnt about reflection of light in which light comes, strikes a surface and returns back in the same medium. But my today's topic is refraction of light in which light passes from one transparent medium to another transparent medium and it deviates from its original path. When a ray of light strikes a surface, a part of it is reflected back in the same medium. This is known as partial reflection. But a part of it is goes to another medium. This is known as refraction of light. Now, three possibilities are there in which first possibility is light is entering from a rarer medium to denser medium. For simplicity, we are not taking this reflected ray of light. We are only discussing refracted part of light, although we know that partial reflection and refraction both are there. Now, first possibility is when light ray is striking a surface, this is the normal and ray bends towards the normal. When ray bends towards the normal, ideally it should go in a straight line, but if it bends toward the normal, it means light ray is entering from rarer medium to denser medium. And oppositely, if light ray enters and strikes a surface and goes away from the normal, ideally it should go like this, but it is going away from the normal, then it means light is entering from denser medium to rarer medium. As you can see in these two diagrams, this is the angle of incidence I and this is the angle of refraction R. As we know the definition of angle of incidence, it is the angle made by incident ray with normal. And this is angle of refraction, this is the angle made by refracted ray with normal. When ray goes from rarer to denser medium, this angle I is greater than R because in denser medium, speed of light reduces and ray bends towards the normal. And in this case, when ray is entering from denser medium to rarer medium, our angle of incidence is I and angle of refraction is R, and in this case, I is less than R because the speed of light in different medium is different. This is the cause of reflection because light has different speed in different medium. Light has less speed in denser medium, light has more speed in rarer medium. It is optically rarer medium, this is optically denser medium. To summarize this, you may take an example कि हम खाली सड़क पे गाड़ी चला रहे हैं, दिस इज रेडेड मीडियम. हम बिजी रोड पे आ गए हैं, दिस इज डेंसर मीडियम. जैसे ही हम खाली सड़क से बिजी रोड पर आए हैं, हमारे व्हीकल्स एक दूसरे के पास पास आ जाएंगे, हमारी स्पीड भी थोड़ी सी रिड्यूस हो जाएगी. तो आप इसको ऐसे याद रखिए कि यहाँ से हम रेयर मीडियम से डेंसर मीडियम में आए हैं तो टूवर्ड्स नॉर्मल बेंड हो गए क्योंकि गाड़ी थोड़ी पास पास आ गई. तो इसमें हमें ऐसे करना है. और अपोजिट इस केस में क्या हो जाएगा कि हम बिजी रोड से वापस से हाईवे पे आ गए, हमने फिर से स्पीड पकड़ ली, गाड़ियां दूर दूर चल रही हैं, फुल स्पीड के साथ चल रही हैं. इट मीन्स हम डेंसर से रेयर मीडियम में आ गए हैं. तो इस तरह से आपको ये दोनों केसेस समराइज करने में इजी हो जाएगा. नाउ थर्ड केस इज व्हेन लाइट रे is entering and angle of incidence is equal to 0 means incident ray normal के साथ ही strike कर रही है. Angle of incidence I is equal to 0 degree. Then R is also equal to 0 degree. This is our third case. In this case, ray go undeviated. So, in first case, when ray is entering from rarer to denser medium, it bends towards normal. Then denser to rarer, it bends away from normal. And if I is 0, then it goes undeviated. Now coming to laws of refraction, which are also known as Snell's laws. Snell's laws. Our first law of refraction is incident ray, refracted ray and the normal at the point of incidence all lie in the same plane. This is quite similar to the second law of reflection. Now, second is the sine I upon sine R is equal to constant and this constant is known as mu, it means refractive index. the ratio of angle of sine of incidence to the ratio of angle of sine of refraction is constant for a given pair of media. This is our second law of refraction, and this constant is known as refractive index of second medium with respect to first medium. It means angle of incidence in first medium and angle of refraction in second medium. Now this refractive index is generally defined as ratio of speed of light in vacuum to the speed of light in any other medium. Now we know that when light is entering from one medium to another, its speed changes as well as its wavelength changes. But one thing which is not changing is its frequency. V is equal to F lambda. It means V is changing, lambda wavelength is changing, but frequency is not going to change when light entering from another medium, because frequency depends on the source from where that light is coming. Now speed of light is maximum in vacuum, or you can say air, and its value is 3 into 10 to the power 8 meter per second. Suppose we are taking other medium as glass, and its speed is 2 into 10 to the power 8. So value of refractive index, absolute refractive index, where this medium is air and this medium is water, or you can say glass, this value comes out to be 1.5. So mu is equal to 1.5. This statement means that the speed of light in air is 1.5 times more as compared to glass, or you can say the speed of light is 1.5 times less in glass as compared to air. So whenever there is change in refractive index, it means there is change in speed of light. But if the value of mu is 1, then it means refractive index of both the medium is same, so there is no deviation. First case we have discussed earlier, when I is 0, then R is 0, mean ray passes undeviated. Second case is when mu is equal to 1, or you can say when the speed is same in both the media, it means refractive index is equal to 1 and there is no deviation in the path of ray of light. Now coming to factors of refractive index, it means mu. Now first factor is nature of the medium, it means its optical density. Second is physical conditions such as temperature, etc. Third is color or wavelength of the ray which is coming. Now, on all these factors, the relation is inversely proportional. It means when refractive index increases, then these will decrease, or vice versa, when they will decrease, refractive index will increase. It means there is inverse proportionality with all these factors. Now coming to principle of reversibility of light, it means the path of light ray is reversible. It means that when coming, this is the incident ray, and light is going to another medium. Suppose it comes towards a normal, it means this is denser medium and this is rarer medium. Then when this ray will travel back from this medium to this medium, suppose this is first medium and this is second medium. When going from first to second, it bends towards the normal. If it is traveling back, it will bend away from the normal. It means it will follow the same path. This is known as path of reversibility. It means 1 mu 2 is equal to 1 upon 2 mu 1. It means the refractive index of second medium with respect to first medium is the reciprocal of refractive index of first medium with respect to second medium. Now this is our rectangular glass block. As you can see, this is a cuboidal shape. Now we will study about the refraction of light through this glass block. When light enters from air, which is a rarer medium, light is entering, it means this is our incident ray, and the angle made by this incident ray with normal is known as angle of incidence I. Now ray is entering from rarer to denser medium. Glass is a denser medium than air or vacuum. Now this ray will bend towards normal, and this is known as refracted ray, and the angle made by this ray with normal is known as angle of refraction. Again on a surface, because refraction is a surface phenomena, whenever it strikes on a surface, it will change its direction. Now again with the normal, it bends away from the normal. Away from the normal because it is now going from denser to rarer medium. But if we draw incident ray, it means it is produced forward, then you can see this perpendicular distance is here. This perpendicular distance made by this ray is known as emergent ray, and angle made by this emergent ray with normal is known as E, means angle of emergence. Now the perpendicular distance between this emergent ray and incident ray produced forward is known as lateral displacement. Now this is a parallel sided glass slab, so our angle of incidence is equal to angle of emergence, but they don't lie along the same line. Now factors on which lateral displacement depends, our first factor is thickness of our glass slab, and second factor is angle of incidence I, and third factor is refractive index. In all these factors are directly proportional with lateral displacement. They are directly proportional. If they increase, then lateral displacement will increase. Hope you have understood the topic. In my next video, we will see all these refractions through prism and glass slab with the help of this optical box which I have made. You can see this side is transparent, this side is transparent. With the help of light, we will study the properties of these refractions.